Welcome to The Explainer. Today, we're deconstructing a machine that pretty much performs the impossible. We're talking about shaping the hardest materials on Earth, not with brute force, but with what is essentially controlled lightning. So here's a huge challenge in manufacturing, right? How do you cut the absolute hardest metals into these impossible shapes? Think about a complex mold or a part with super sharp internal corners. How on earth do you do that? Well, the answer isn't about hitting it harder. It's all about incredible, mind-bending precision. And the secret? It's a process called electrical discharge machining, or EDM for short. Now get this, there's no cutting tool that ever physically touches the metal. Instead, EDM unleashes this crazy series of intense, rapid-fire electrical sparks. We're talking tens of thousands every single second, that basically melt and vaporize tiny microscopic particles of the material. It just carves it away with absolutely stunning accuracy. All right, so how do we get from just a spark to a perfectly finished product? Here's what we're going to cover. We'll look at machining with sparks, then we'll dive into the anatomy of the machine itself. After that, we'll see how it goes from a blueprint to a finished product, check out its super complex global supply web, and finally, decode the machine's digital DNA.
First up, the anatomy of the machine. You know, an EDM machine is really a fusion of three totally distinct systems. You've got the mechanical structure, an electronic powerhouse, and a fluid circulatory system. So let's start with the skeleton. Okay, so the body of this machine is its skeleton, and it has to be unbelievably rigid and thermally stable. It's usually built from this massive cast frame designed to absorb every little vibration. And here's why that's so critical. Because the process is non-contact, any tiny error from heat or movement would completely ruin the part. So this skeleton, combined with hyper-precise linear guides and motors, is what guarantees that mind-boggling micrometer level of accuracy. But if the frame is the skeleton, the real heart of the EDM is its power supply. This thing is an incredibly sophisticated piece of electronics. It takes just standard factory power and transforms it into those rapid-fire, high-frequency pulses that do all the work. Honestly, it's less of a simple power supply and more like a super high-speed digital switch.
And yeah, this is really where the magic happens. Let's break down what's inside this power supply. You've got these IGBT modules, think of them as ultra-fast electronic switches, just flipping on and off, creating the pulses. Then you have custom circuits, often using specialized chips, that perfectly shape each electrical pulse for whatever material you're cutting. And this is the really clever part. A servo interface is constantly sensing the voltage, maintaining that perfect microscopic gap that lets the spark jump across. It's an incredible balancing act. Of course, none of this works without the machine's lifeblood, the dielectric fluid. This is this special, non-conductive liquid, usually in oil or deionized water, that the whole workpiece is submerged in. And it does three absolutely critical jobs. One, it acts as an insulator until the voltage gets just right for a spark. Two, it cools the whole process down. And three, maybe most importantly, it flushes away all those vaporized metal particles, the sludge, to keep the cut perfectly clean. All right, so we've got the components. But that brings up a really interesting question, right? How do you actually build a machine that in its own construction demands this insane level of precision? Well, it turns out it's this fascinating blend of old-world craftsmanship and pure 21st century tech. Get this, the main foundational surfaces are often hand-scraped by incredibly skilled artisans. Yeah, by hand. This process creates this perfect network of tiny pockets that hold oil, and it achieves a level of flatness and stability that modern machining just can't replicate. Then, after all that, they bring in the lasers, laser interferometers, to verify that mechanical perfection before the final digital calibration. It's amazing. And this slide just lays out that whole journey perfectly. It all starts with machining and stabilizing the raw castings. Then comes the really complex part, integrating all the electronics with tons of careful shielding to stop any interference. After that, the fluid system gets plumbed in and pressure tested for leaks. Then the lasers come back out for calibration to electronically compensate for any final microscopic errors. And to top it all off, every single machine has to pass a real-world cutting test to get its own unique accuracy certificate. No exceptions. Now, building one of these machines, it's not like building a car. It's not even like building a traditional milling machine. To make an EDM, you need a supply chain that is a wild convergence of totally different industries. And here's the crucial point. Look at a traditional machine, like a milling center. Its supply chain is all about heavy industry, foundries, bearing makers. Its biggest risk is the price of steel. But in EDM, its supply chain is dominated by electronics. Its biggest risks are tied to the totally unpredictable semiconductor market. Just like Apple or Samsung, it's a completely different ballgame. So this forces the manufacturers to get pretty creative with their strategies. Some of them choose to vertically integrate, meaning they start making their own critical electronic components, like the power supply, just to control their own destiny and reduce risk. It also creates that classic razor and blade business model, where a huge chunk of the revenue comes from selling the essential consumables, like the wire and the filters. It's a smart play because it gives them a steady income stream and a real competitive edge. Okay, finally, let's get into the data side of things, the digital DNA that underpins this entire operation. It's all built around something called the Bill of Materials, or BOM for short. And you can basically think of it as the master instruction manual for the whole machine. Yeah, digital DNA is the perfect way to describe it. The BOM is the one single source of truth that defines every single nut, bolt, circuit board, and even every line of code. It's the blueprint that literally translates an engineer's idea into a physical machine on the factory floor. But here's where it gets complicated. There isn't just one BOM. Nope. The engineering department has what's called an EBOM, the engineering BOM. It's organized by function, and it defines what the machine is. But the people on the factory floor, they use an MBOM, the manufacturing BOM. It's organized by assembly steps, and it defines how to build it. So you've got two different blueprints for the exact same machine. And you can probably guess what happens next, right? A communication gap opens up between these two documents. An engineer makes a design change to the EBOM, but it doesn't get updated in the MBOM fast enough, or part numbers don't match up. Even something super simple, like the exact type of sealant needed for a fluid tank, can get missed. And all of this leads to errors, wasted time, and major delays on the factory floor. So, the best manufacturers have figured out how to solve this. They create what's called a digital thread. They use these really sophisticated software systems to create a single, seamless flow of data. So now, any change an engineer makes to the EBOM is instantly and automatically reflected in the MBOM. It makes sure that the designers and the builders are always working from the exact same playbook. So, let's wrap this up. What are the big takeaways? First, an EDM isn't just one thing. It's a fusion of mechanics, high-power electronics, and chemistry. Second, its supply chain is a unique beast, facing risks from both heavy industry and the electronics world. And finally, and maybe most importantly, data is king. That digital thread connecting the engineering blueprint to the manufacturing blueprint is just as critical as any physical part of the machine. And that leaves us with a final thought to chew on. As every machine gets its own network of sensors and data, its own digital DNA, what happens when the digital thread of just one machine connects to the entire factory? Well, when that happens, we're not just building better machines anymore. We're actually building smarter factories.